All right, so we are going to continue with homework here for 4.1. There was questions about 39. Okay. So let's see. This is 39. Okay, so the problem starts off with there is a light pole. There is a kid. There's the ground. And we have a shadow like this. And this guy is 1 meter tall. The light pole is 6 meters tall. And what else did it give me? It gave me like,
If the child walks away from the light at the rate of 20 meters per minute, how fast is the child's light moving? That's the only other stuff they give me.
right there. Okay. I struggled myself on this. It took me a while, and I was like, oh yeah, I gotta use the ratio, but every formula I tried using gave me some type of change that I couldn't use. Because I did similar triangles. So let's break out similar triangles here. So we have the big triangle, which that was a 6. We have the little triangle, where that is a 1. Right? So I was seriously having trouble with this. Both of them were, because I needed at least one more value, and I didn't have another value. So that's why I was really struggling with this. And so I had to go and say, all right, so a couple things. I know that this one right here is going to be my, let's give it the X that I'm looking for. And since this is also the same as this triangle here, right? And there's some value over here on this side that it would be. So I had to try and set it up like, all right, so whatever the distance is here. And so, yeah, it looks kind of weird, but it's going to help me out with my proportions. So every single time when you do this, I have to set up a true equation to be able to do this. And I only have one, this is going to be like a dx dt here, right? So, all right, so from here, I'm going to set this up. So in my ratio, I'm going to set up the ratio, and this is going to be d plus x. So this is all I have. And so I'm going to have to actually go through and actually try and find this. So I have a dx dt here, or a no, this is a dt. Because with my little person here, this piece right here is the piece that's changing. Because that's the distance from the light pole, right? For the kid. So I have a change, which would be a distance from the light pole over time. There we go. And now I'm going to set up my proportions. I'm going to say 1 over 6 is equal to, what would my proportions be? If it goes 1 over 6, how would I set up the second fraction? Go ahead, Christian.
E plus x over x.
So look carefully. So if the 1 is on top, then what needs to be on the top on the other side? 1. The 1's on top. That's this triangle here is on top.
Right.
So therefore, yeah, you get x. So the proportions have to be equal. So this side to this side, and then x to whatever my large triangle. So small over big is equal to proportions of small over big. That's where we get D plus X. And this is all I got out of this. And so it took me such a while because I only could have one direction, because otherwise I had a Y, but I didn't have any more values. I had an R value, which is the hypotenuse, which is also changing, but I couldn't actually isolate that. And they have thetas, which I also would, all of them they have the same thetas. So that didn't help me out at all. So yeah, set this up, let's do cross product. So if I multiply this, it's gonna give me distance plus X is equal to 6X. Subtract X from both sides. I get my distance is equal to 5X. Are you guys okay? Question? Juju? Christian? Were you following? Okay. Alright, so I set up a true statement here of my proportions. I did this. Now, I can take the derivative of both sides. Because in this case, I'm going to be looking for the X value. So I'm going to be looking for the dx dt. I'm going to be looking for that because that's going to be the distance of the shadow right here. The distance of the shadow changing. So my derivative d dt is equal to 5. Derivative of that is going to be dx dt. And since I'm trying to get this, I'm going to divide both sides by 5, right? My dd dt is 20. And I'm divided by 5 is equal to my dx dt. Do the math and I get 4 meters per minute.
How'd you get that 20 over 5 again?
Okay, what's dd dt?
Oh.
That's 20, right? And I divided by 5 because right here, it's multiplied by 5, right? So that's where I get that.
Oh.
Alright, does that make sense? A little bit better? Sherilyn? Go ahead.
Did you do 25?
25?
Yeah.
Did I do 25 already? 24. Wait, 3. I don't have a problem doing it. It's just,
No, I don't.
if it's one that we've already done. Let's see what 25 says.
Let me take a look at 24 while we're,
Oh, well, I'm doing that? Okay. I'll back up to 24. DHDT looks like it finishes over here. Oh yeah, that's why we did. I did do it. I can't remember who.
It was just three of it. You didn't do it on the board, I think.
Okay.
Just three of us who did it.
Are you good, Vincent?
You said DV is DT is.
Huh?
Is DVDT given 16?
Yes. That's right here, and it's DV.
Well, I thought it was like a dispute.
24,
That was a celebration.
It's a one.
H is 3.
It looks like a dispute, isn't it? Not all like cans.
How does it sound?
Come on, biscuit.
I wanna see that. It looks as fun. I wanna check.
Yeah, it should be 20 centimeters cubed per second.
It's cause the answer on the next page.
It might not be the same problem, so that's why I'm wondering about. Because I get height is going to be there. So we did this
Yeah.
to figure out the R. Alright, replace R with H's. And then I took the derivative here.
It should be 5/9 pi. That's all.
I plugged in. Why did I plug in 16?
That's why I got confused with.
And it was where H is 3, right?
Yeah.
Okay, okay, yeah, I guess I messed up when I was doing this, so thank you for that. You have earned a sacrifice. So you're saying that one's supposed to be 20?
Meters cubed.
Yeah, so 20 equals 36 pi.
Yeah.
dH dt.
Sorry. You got it wrong ago, huh?
And what's that, 5/9 pi?
Yeah.
I wish someone would have caught that last time. Where'd 16 come from?
What question is it?
24.
I think you did. Wait, it was 16.
Maybe I just didn't even do this.
Yeah, so I'm like,
I don't think I did that.
it was supposed to be 20.
How's it going?
Anyway, yeah. Alright, you said 25?
Yeah. More specifically, B, but you can do it.
B? What'd you get for A?
A, I got 4/3 pi.
4 over.
4/3 pi.
Okay, so part A is 4 over 3 pi represents what?
The change in height.
dH dt. Right?
That's all I got.
Okay. So if it's that, then this what it should be mathematically. Right? That's what it should be mathematically. But it says if when the water is 3 meters deep, it is observed that the water rises at a rate of 0.5 meters per minute. What's the rate the water's leaking from the tank? So we're going to compare the volumes now, the dV dt. So in this first one, what was my dV dt?
It's given.
As
DVDT is 3.
3 what?
Meters cubed per minute.
Okay, so that was the first one, but now we're going to use this. We're going to use this right here to actually work it out again. So they said that for part B, my GH dt is 5, right? 0.5. Is that correct?
Yeah.
Yeah. And minute?
Yeah.
Okay. So plug it back in. So I have my volume problem. V equals, since I replaced it, it was, I know the height, so it should have been like, pi, damn it. I'm trying not to, okay, so I'm gonna have to do this one real quick because I gotta make sure it's the right. So on 25, it said, because I have to go back and do A, I can't just jump to B.
Yeah, we got 16 over 3 pi for A.
Yeah. What was the formula? What was the derivative for my V? So V equals, after I substituted for my H,
We got V equals 1/3 pi times H over 16 times H.
H over 16 times H, right?
H squared over 16. Yeah.
Like that?
Yeah, like that.
Over H squared. Oh.
1/3.
Is it,
Yeah, 1/3 pi, and then it's just
Oh,
H cubed.
it should be over 4, not 16, right?
I think that we got over 16 because
We
that
squared
was
that.
after we squared it.
Okay, so
that's
yeah.
how we got the 16.
Okay, so I'm just making sure because I don't want to redo the
Yeah.
whole problem over again. So this is H squared over 16 because the 4 worked out.
Yeah, so it was H over 4 squared times H, and then we just.
Okay, then combine. So you'll see this here in a second. So 1/3 pi H cubed. My board's not working. Come on. Come on. 16.
Yeah.
So when I do the math, I'm going to multiply and do the derivative. So I get dv dt. That 3 is going to cancel out there. So I'm going to get pi over 16 h squared dh dt when h is what? When it said h is
3.
on this one, yeah. 3 meters deep, okay? So my dv dt is pi over 16 times 9 times 1/2. Because my dh dt is 0.5, which is 1/2, right? And do the math. What's that? 9 pi over 32, which comes out to be like
9 pi over 16.
9 pi over 16. Why do I have a half then?
Because you're looking at B.
Oh, yeah. You don't have the 1/2 yet.
Okay,
Yeah, there is.
so dv dt 9 pi over 32 do the math on that one, what do you get?
Just 9 pi over
Yeah.
16.
9 pi over 16. Well,
Yeah.
why do I have it 1/2 then?
Because right here for part A, we never added the 1/2. You kept it as 3 equals 9 pi over 16 times pH over dt for that one. Yeah.
This is when we're solving for DHDT, and that's when you get the.
I know. You have DHCT, and DHCT was
48 over 9 pi, and then we simplified it, which gave us 16.2.
this is part B?
No, that's part A. Part B starts.
Oh yeah,
with
part B is here. This is what I'm looking for here. Yeah, 9 pi over 32. We're just doing part B.
Oh, we were part B.
Yeah. So yeah, 9 pi over 32. You'll see in a second. So yeah, so dV dt is 0.883.
Yeah.
So this dV dt minute. Okay, so that's my actual. And mathematically, my dV dt should be right here, right? So, and it's asking how much is leaking. So if this is what I actually have, but this up here is what I'm supposed to have, I'm going to subtract, and it's going to be, was it 2.117? That's my leak. Because these two things are not the same. So mathematically, it says we're supposed to have 3 meters cubed per minute, right? But the actual amount right here is going to be 0.883 meters cubed per minute. And the difference, the delta of those two, the difference in between, that's how much I'm losing. That's the leaking part. Isn't that what we got on the last part for B?
Yeah, 2.116.
Okay. Yeah. Vincent? Yes? That makes sense or no? Because this is your question.
Run through it one more time.
Huh?
Run through it one more time.
You zone out on me?
Yes.
Okay. Alright, where'd you zone out?
Right after you got 9 pi over 32.
Okay, so this, are you okay with this? That 9 pi over 32, that is my dV dt. This is when I plug in this of my 0.5 meters cubed per minute, right?
Okay.
So that's the new value. This is the actual value that we got.
Yep.
I approximated this to be this right here.
Yep.
So this is the actual one that I have. This is what I'm supposed to have right here.
Yeah.
So mathematically, we're supposed to have that much, but right now we have that much. And so the difference in between those two is my leak.
Okay.
Yeah, that's what we got.
And also, I realized that I messed up all the way from A.
Oh.
I know it said diameter, but I still put the diameter as radius. So
Isn't that super annoying?
yeah.
I do that all the time. Alright, do we have enough time to actually do any more? We don't have time for notes today, do we? Huh? Oh, we got 12 minutes. So I really need to actually progress on these notes because this is gonna 4.2 is gonna be kind of long anyway because we have several parts to it. I want to at least finish the examples we were doing. cause we were right. We were doing these ones, right?
Huh?
So, we did the R,
Yes.
we did the G, we did not do,
I'm just gonna come in here and start filling that.
okay, we didn't do the capital G. This is the last one, part D. That's the one that we didn't do yet. So part D is what I'm gonna do. So capital G of X is equal to sine X. Alright, go ahead, take the derivative. So derivative of sine is cosine of X, and this whole unit 4.2 is about doing what? Set equal to? 0, very good. 0 and what else? Undefined, very good. Man. Alright, so 0 and undefined. So let's go 0 equals cosine of X, and now I'm gonna arc cosine this. So inverse or arc, whichever you wanna call it, so it's gonna be X equals inverse cosine of 0. So what this is saying is, for my X value here, when is cosine equal to 0 on my unit circle? Okay, so it's gonna be pi over 2 plus, not 2 pi, because 2 pi will put me back on pi over 2. Is there any other place on my unit circle that it is also 0? At 3 pi over 2, right? So how would I get from pi over 2 to 3 pi over 2? Add pi, right? I'm gonna add multiples of pi, and that's gonna keep getting me back to the same thing. So it would be n pi. So this one right here, is gonna give me, so at my 0, right, my first, it would be 0 here, and then it would give me pi over 2. And to get to the next place, it would be n is 1, so I would give me 3 pi over 2. And at 3 pi over 2, n would be 2, and that would give me back up to pi over 2, right? So as it keeps going, those are all the intervals in which that it is going to be equal to 0. Does that make sense? Because sine is a wave, and I just have to count it every single time that it's gonna land on that spot. Let's see. Locating extreme values. Let f be a function that is continuous on a closed interval from a to b, then the absolute maximum value and the absolute minimum value of f are the largest and the smallest values, respectively found among the following. The values of f at the critical numbers in the open interval, okay, from a to b, and f of a and f of b, those are my endpoints. The values of f at the endpoints a and b. So we're checking all those. So we check those values. So plug them in. We can actually plug it in to actually see what we get at the endpoints. Steps are finding absolute extreme values of function that is continuous on a closed interval. That's important. Locate all critical numbers in the open interval. That means not including a and b. So it's going to be every place in which that's going to be. What am I looking for in between those 2 points? 0 for the derivative. Yeah, you guys are getting there. Okay. So 0 for the derivative, right? That's going to give me a critical because for all this, my derivative equals 0. So that means that I'm going to actually have a slope of 0. What else in from A to B am I looking for? Undefined, right? Undefined, places in which that I can't take a derivative of, or undefined. Evaluate each critical number and the endpoints A to B. So largest value is the absolute maximum, the smallest value is the absolute minimum. So we're at least going to plug in 3 things. 2 endpoints, something in the middle. And let's see what right here. Find the absolute maximum and the absolute minimum value for each function. So I'm going to do this new page. So it says f of x equals x cubed minus 6x plus 9x plus 2 from 0 to 2. Okay, let's find the derivative. And then from the derivative, I need to set it equal to 0. All right, so f prime of x equals 3x squared minus, that's supposed to be a square, 12x plus 9. My interval still from 0 to 2. So first thing we do is we find critical points. And I want to find critical points that are located in between here. If they're not here on my interval, Juju, are you paying attention?
Yes, sir.
Are you zoning out? Okay. You got this. Those people are trying to keep you down. Alright, so I only want the points that are between 0 and 2. That's it. Anything else I don't really care about. Set it equal to 0. Factor out of 3. And factor, divide both sides by 3, so this goes away. So 0 equals quantity of x. This is going to be, what's that going to be? Minus 3 minus 1. Zero product, so that gives me that x is equal to a positive 1 and x is equal to a positive 3. The only thing I care about is my domain. So what does my domain tell me?
X equals 3 doesn't matter.
That one doesn't matter, right? That's good. So now we're evaluating at those points. So when I evaluate something, where do I plug it into? F of x. Not f prime. We want the y value. So what is going to be the largest y value? So I plug it into the original. So if you guys have your handy dandy calculator, you would do f of 0 equals f of 1 equals f of 2 equals. Okay, so let's go to the graph. right here, and that was x cubed, right?
Yeah. 6x
Minus 6x squared
plus 9x.
plus 2.
Yeah, plus 2.
There you go. Hit enter. And let's go back to that trick that we did. So over here, bars, use that one. F of 0 is my first. Do it again. F of 1. There we go. Do it again. F of 2. Alright, what is my minimum? My minimum is 2. Okay, that's one f of 0. What's my maximum? F of 1, right? Wait, hold on, it was 2 for this one here. And this one right here is just my 4, which this is gonna be neither. Yeah. Alright, make sure you all like, share, and subscribe.